Hi, I'm Bob Vila. Welcome home again to our little farmhouse here in Medford, Massachusetts. Today we're insulating blown-in cellulose, both in a new construction application and as a retrofit. Also, we're doing some of our initial internet wiring, structured wiring that is. Stick around, it's good to have you home again. Let's get started in the former barn, now artist studio space. Joe Sheridan is here from Energy Guard, and he's going to tell us all about cellulose installation, right?
How you doing, Bob?
Good. Now, Joe, this is an unusual situation that we have here in that we've got an old attic, a barn that's being converted into 2 studio spaces,
Exactly.
a garage portion which will be unheated.
Yep.
How do we get started here?
Well, in this area, the first thing we have to do is back the walls with this mesh material so that when we spray the product on it, it has something to hold it until they get the sheetrocking.
Gotcha. And this is a similar product to what you see in the bottom of upholstered furniture, right?
Yes, the bottom of a couch, the same type of material, just a woven
Now,
material.
the cellulose itself is ground up newspapers, right?
Exactly. 40 years worth of reading.
That's what somebody told me. It's
yeah.
the equivalent of 40 years worth of newspapers recycled into the average house.
Exactly. Yesterday's news.
Are there any drawbacks from the point of view of humidity getting into it or rodents or the like?
The borates that the product is treated with are resistant to fungi, to all kinds of bugs.
Basically, boric acid is what
exactly.
they treat it with, right?
Right. And in terms of the wood or anything like that, it doesn't have any effect on the wood. It actually will resist these things more than the wood itself or the other material.
You mean the water that's used in the application?
Yes.
In the installation?
Right.
Okay. Are they ready to get started?
They are.
Okay, let's watch, because I know that this involves blowing the cellulose into the wall cavities, but also mixing in a little bit of moisture so that it stays in place.
Exactly.
There you go. Now, it's kind of messy, though. Don't you waste a lot of product like this?
Well, Justin's going to come right in behind him with a vacuum cleaner, and that's going to take the product back to the truck where it remixes with the paper and then comes back through the hose that Brian is holding.
All right, so one fellow's making the mess but leaving behind a fair amount in the stud cavity while the other fellow picks up the mess.
Right, and there's a little bit of overshoot here, which they'll come back in a few minutes with a stud scrubber and bring that so that it's level with the studs so the sheetrockers can come in.
So the objective is to really pack it in dense, right?
Yes, you do want a nice tight fit to eliminate all air movement and through the wall cavity.
What's the R factor that you can achieve in a 2x4 stud wall?
2x4 you have R13, and with a 2x6 you have R21. Also, it tends to hold its R value in extreme temperatures. When it gets much colder, like 20 degrees, 15 degrees, it holds its R value.
One thing's for sure, though, this is not a do-it-yourself application. You can't go out and rent the equipment to do this, right?
The learning curve would be too much.
Yeah. Okay, so Joe, what he's using here is, what did you call it, a stud?
Stud scrubber.
Scrubber.
Yep, and that basically brings the product flush with the studs so that when the sheetrockers come in, they can apply the sheetrock without any issues.
All right, and what keeps it all from crumbling out is the moisture that's been put into it right now in the application.
Right.
Is the boric acid mixed in with the water, or is that something that was applied to the cellulose when it was shredded?
When it's manufactured, they apply the borates, they apply starch to help it stick to netting, and the wood is all applied at the time of the manufacturing.
Now, from the point of view of the moisture content that is used to apply this, isn't that a problem?
No, within about 24 hours, this will drop down to less than 25% moisture content of the product, which will allow them to sheetrock as long as they're below the 25%. So unless you have an excess amount of moisture, it's not an issue.
Okay, let's take a look upstairs and see how we're using it up in the roof rafters, right? So I suppose one of the advantages of this product is sound attenuation, right? It'll kind of deaden the space.
Yes, because of the density that we actually blow the product in, the sound, just like the air, the sound can't travel through it as well. So it really does deaden up the sound.
Yeah. What's the brand name for this?
This is a cocoon made by Green Fiber.
I gotcha. Now, how is the process any different up here?
Well, here Sean's doing a dry application where we're blowing in under pressure. He'll feed the hose down to the bottom of the cavity, and then as it fills up, he'll pull it back, and he can tell when it's at a dense state.
Sure. So this is packed in there. Don't you have to provide some sort of ventilating proper vent or something like that?
Well, the purpose of the proper vents is to stop the warm, moist air from coming in contact with the cold roof sheathing. In this situation, because of the density that we're blowing it, the air never travels through the insulation, therefore the moisture never gets out to the roof sheathing.
Because the moisture is airborne, you're saying?
It's airborne, 98% of the
Sure.
moisture.
But what about if you have a leak in the roof?
Well, that's an issue, but it's an issue whether you're blowing this or you're installing fiberglass. If you have a leak in the roof, you have to fix the leak.
You have to fix it sooner rather than later.
Yeah, exactly.
Because if you do get humidity and water into the product, you're going to eventually have a big problem.
Right, and it can be an issue. If with this product, it could be worse. You'll see the problem sooner than later.
Yeah.
But the problem is still there.
And what about the cost, comparatively speaking?
It's very, very close to fiberglass, the market price of fiberglass.
Okay. Now, I noticed down below we were also installing it around where we have water pipes and waste pipes. How does that work there?
Well, basically, again, because of the density, it's going to absorb all the sounds of the pipes, all the waste pipes and water pipes. It's going to absorb that sound. So we do a lot of soundproofing.
And you are going to get a good R factor there.
Yes, you would get the same R factor.
Okay. Thanks a lot, Joe.
Very good, Bob. Thank you.
When we come back, we'll start framing a balcony outside the second floor master suite. Stick around. There's lots of action on the back side of the house today. Let's start by looking at what's happening right here. Mike Donahue is here from American Standard. How you doing?
Bob. How you doing today?
Now, this is the part of the air conditioning system for the studio, for the barn.
True.
And what do you call this?
This is a condensing unit.
The condensing unit. And what does it do?
We dissipate the heat, we take it from inside, and this is where we eliminate the heat. This is where we
Okay,
get rid of
so
it.
this is an American Standard, made in the USA. There's a finish on it just like an automobile practically.
Yeah, well, they put it that way on purpose, Bob. They call it powder paint. A lot of safety concerns. You can actually run a finger right on it without any problem.
And kids like to play around these
Very
boxes.
much. It's
yeah.
the biggest thing in the yard. We figure the kids will get on top of it, so the safety concerns. We've also done ceramic-coated screws, so there'll be no rust on the unit ever. So,
Now, you've got this loose so we can look inside, which is the fun part. And can we just lay the fan down? This is the lid. It's got a little motor and a fan, but what do you call this?
this is called spine fin. It is a patented heat transfer agent that
and it's
we use in
basically
American Standard.
the copper pipe that has
The refrigerant.
the refrigerant,
Yeah,
exactly.
refrigerant.
And then this is helping to dissipate the heat that's concentrated in there.
Right. It's the most efficient heat dissipator, aluminum upon aluminum.
Can we take this jacket off of the,
Yeah,
this
this
is
is
a
a
compressor, right?
Yeah, this is a sound jacket, again, to drop the sound
Oh,
down
that's
a little
good,
bit.
yeah, so that it's not as noisy. And then what are we looking at here?
This is a scroll compressor. It's newer to the market. Scroll is the big name now in our industry.
Instead of a reciprocating compressor.
Instead of a reciprocating, yes.
And so what does that do for us? What's the advantage?
Well, we can get more efficiency out of it.
I
This
see.
happens to be a 12 SEER unit. SEER is a seasonal energy efficiency rating. The government has mandated that in 5 years, this will be the minimum, the 12 SEER.
The 12 SEER.
Right. But we have these units can take it up to, we have 18 right now.
Excellent. And what kind of life expectancy can you expect from a unit like this?
Well, the compressor and the coil both have 10-year warranties on them and 5-year parts. But from 10 on, depends on the part of the country, you can keep going and going.
Yeah, one of the big problems is rusting out on this on the casing, right?
Right. Again,
And-
salt air is an enemy, but the aluminum on aluminum helps, you know.
And the
increase
powder
efficiency.
coating also increases life expectancy, I imagine. Thanks a lot, Mike. Okay,
Okay.
let's check in with the carpenters over here. All right, well, as I was saying earlier, there's a lot of action on the back side of the house, but first let me make an observation about the design of this, this addition, this connector, if you will, between the old house and the old barn. The two buildings were not parallel to each other. They were a little bit askew. So the choice that the architect made was to build the addition itself and the breezeway connection parallel to the barn. It's at right angles. But then the roof is right onto the house. So that what happens is when you look at the roof overhang right here on this corner of the addition, it kind of increases in width in one direction. They're not parallel angles. They create an effect that's quite unusual. It'll be interesting to see once everything is painted out here what it looks like. But up here, we've got a lot of construction going on in terms of another unusual feature of the architect's design. This door that you see on the second floor leads out of the master bathroom. And the owners decided they wanted to have like a little balcony out here. It's not quite a Romeo and Juliet balcony because the shape is 4 feet wide and it comes out 10 feet, kind of like a gangplank. And we're going to look at how they're building that in a minute. Right now, let's talk with Charlie. Got enough nails in it, Charlie?
I think we got a few in there.
Now, this is a temporary post or deadman, and what you've got here is your frame for this balcony, right?
A 4.5 foot by 10 foot frame.
All right.
For the balcony.
What's the game plan? We're going to hoist it
Game
up
plan
in
is
place?
to hoist this up and get it up onto the staging, slide it over there, put it on the cleat, put the 2 dead men underneath it, and then we'll support it all afterwards.
Let's
we
try
can show
it.
you the hand here.
All right. Two to climb. And bring it up against the sidewall where we have a temporary cleat already in place.
You all set right there? Yep. Okay. In. And you want to get on one on the back and one on the front to lift it in. Slide more this way, go right underneath the plug. There you go. Set it down. That's it.
All right,
Temporarily
let's put a
supported.
few nails in place. All right, that ought to keep it safe. Now, Charlie, the original intent here, the architect's idea was to reuse these old porch posts that
Right.
were part of the back entrance. Are we going to be able to, or what's the story?
Well, we thought we were going to be able to rework these. They've already been reworked once before. The problem that we run into when we opened them up, took a look at them, is that they're hollow.
Yeah, they are.
To
That's
try to
interesting. So
extend
structurally-
3.5 feet to them
Oh.
wouldn't be a structural.
You'd have to make them 3 feet longer, which would involve a lap, but since
Correct.
they're hollow, not a good idea.
No.
So I guess we'll check with the architects, but maybe just a regular post.
Could be just a regular post.
Well, it's going to be interesting.
It will.
Coming up next, we'll be working on the structured wiring that'll make this a connected home. We're in the basement, and Tim Woods from the Internet Home Alliance is here with us today.
Hi, Bob.
And now we are doing a huge job here for this house, right, in terms of internet connectivity
Yes,
and
we are.
all the features in the house. You are surrounded by wires in every direction, and of course, trying to get things wrapped up before we insulate. This is all regular insulated cable.
Right.
But, oh, this is not.
No.
Tell me what we're looking at here.
Well, this is our network connection center from Home Director, and this is where all of our structured wiring comes in and where the main control happens.
Right.
We've got our 2+2, which is our Cat 5 and our RJ.
These titles confuse people. I mean, our 2
Yeah.
plus 2 plus, which is our, what does that mean?
Well, people remember like cable. You know, the cable coming into your home for like cable TV and things like
Right.
that. Then you've got Ethernet, okay? That is basically souped up telephone line.
High speed.
High speed, and that allows you to network all through the home, whether you're using the cable or the Ethernet. And we bring it all into this box. We also bring in our connection to the outside world, which is going to be our cable broadband application. We're going to have our security link up in here, our telephony is going to come in here, our phone lines are going to come in here as well. And we've got just a ton of wires in here, like you said, because we're trying to do a couple of different things in this home that have never been done in some other homes.
Now, this is a distribution center.
Right.
And we've got essentially a dual career couple living here.
Right.
they won't necessarily be working out of here all the time, but they do want to be able to address their career interests and needs from the home.
Exactly, and that presented a great challenge for the IHA, because what we did is we wanted to not only connect them with each other in the home between, like, say, the home office and the studio, but we also wanted to connect them to the outside world in a broadband environment. So the challenges between the two, running video and all those other things, were great.
Gotcha. Let's take a look up in the kitchen to see how things are going to be running up there.
Cool.
Well, here in the kitchen area, we have Larry Hicks from Home Director, who's helping to run some of the cable. Hey, Larry, how are you?
Hey, how are you, Bob?
Now, what is this going to be doing in the middle of the kitchen?
This is going to provide a universal 2+2 outlet for TV, telephone, or data.
Or data. And it's being aimed at the portion of the kitchen plan where we're going to have kind of the eat-in area.
Right.
Because we have benches here, and so if they want to have any kind of equipment here, whether it's a phone or a screen or whatever, they're all set.
Exactly. They have flexibility.
We've got a plan here, so maybe we should take a look at this to understand better what it is you're doing throughout the house. You want to walk us through from the front door?
Sure. Well, here at the front door, we've got our security camera. And then we've got our ADTI center. That's our security system. As we walk into the home, we basically got our study, screening room, the living room, the family room, the kitchen, where we are right now.
Well, go back to the study screening room, as
Sure.
we're calling it, which is a real media center. What's happening in there?
Well, it's amazing, Bob. I mean, we've got a lot of cable running because we've got speakers all through the ceiling. We're going to be running like Dolby stereo through there.
So this has already been pre-wired.
Exactly, exactly. Our broadband is going to be coming in here. We're going to have high definition TV in there as well. And then you'll see throughout here we've got speakers through the whole house because we've got an audio center actually controlled in the kitchen that allows us to distribute audio throughout the different rooms of the home based on preference. So you can actually have different types of audio playing.
So wherever you see one of these symbols, it's a speaker in the ceiling, right?
Exactly. And then over here, this little blue box right there is actually our Cisco AirNet. That's our wireless.
Okay, now this is the breezeway that connects the barn to the house, and
Right.
there's also an entryway.
Right.
And what does this do?
That is actually our AirNet system. That's our wireless network for the home. So we can actually put wireless cards into our laptop, and it allows us to port the web anywhere in the house.
Right. Now, Larry, what are some of the disadvantages of, old construction like you got here?
Well, with a house this old, it has a lot of lath and plaster in it, and it causes you to have to use different tools to run it through the wall.
It's a slower approach,
Oh,
right?
much slower.
Yeah.
You have to be very careful with the walls.
Right. But we'll get it done, right, guys?
Exactly.
We got a plaster here next week.
Okay.
Thanks a lot. Next, we'll be insulating the part of the house that still has the original plaster walls. All right, well, we're back inside, and we're doing a little insulation on some of the walls in the house that never had the plaster torn off. And Joe, this is a different kind of application. How does it work?
Basically, we have to drill a hole every 16 inches so that we're into every cavity. We have to drill one high and then low so that we get the proper density in the wall cavity.
So first you apply it to the bottom.
Yep, exactly.
And fill it up till it's solid in there.
Right. It takes about 30 seconds on a bottom cavity. He's in a shallow one here, so it won't take quite as long.
But how can you tell when it's full?
You can tell from the pressure of the hose. It'll start backing, the product will start backing into the hose.
Oh, okay.
And you can hear it, if you've done it enough, you can hear it.
And then what you're looking for is to create maximum density in each one of these cavities so that there are no air pockets left, right?
Exactly. Yep.
Okay.
And you could hear, I don't know if you could hear that, but you could hear it tightening up in the flow of the product.
Okay, so once you've filled them all in, how do you plug the holes in the plaster?
Well, in this case, because we're coming from the inside, a plaster will have to come in and patch each hole individually.
Okay. Well, thanks a lot, Joe. That wraps things up. Come home again next time when we'll be installing a beautiful red cedar trellis and lattice fence. Also, we'll be putting up blue board for a skim coat of plaster and drywall for tape and joint compound. Till then, I'm Bob Vila. It's good to have you home again. For lots of information and resources for your home improvement project, check out my website at bobvila.com.